Okay, so now let's just do everything backwards. We just spent quite a bit of time starting with an equation, coming up with the graph. Well, now we're going to try to start with a graph and produce the equation. When we had the equation, we found the factors. If we were lucky, they gave them to us, and then changed the factors into roots, noting whether or not there were any multiple roots, any double or triples. Once we got the roots, we could use them and the intercepts to get the graph. So now we're going to do it backwards. We're going to start with a graph. From the graph, we're going to find the roots, translate the roots into factors, checking out whether or not there are any multiple roots. And from those factors, we can write the equation. So, from this graph, what are the roots, which are also known as the x-intercepts? Well, the graph crosses the x-axis at 1, and it bounces at x equals 4. So we have x equals 1 is a root, x equals 4 is a root. Double or triple roots? Well, because it bounced here at 4, that means at x equals 4, that's a double root. So now we'll translate these into factors. If x equals 1 is a solution, then x minus 1 is a factor. Similarly with x equals 4, it must be x minus 4 that's a factor. But we have two factors of x minus 4. Because it was a double root, we knew that because it bounced off the x-axis. Okay, so we can complete the equation. Notice there is no scale here on the y-axis. We don't know what the stretch factor is. We don't know if this is going up as high as 5, if this is going up as high as 1.5. We don't know what the scale is. So we're going to use the letter A to represent the leading coefficient because we don't know what that multiplier is. So we're going to have y equals a times x minus 1 times x minus 4 times x minus 4, which will probably be condensed. They don't expect us to multiply all this out, but they would expect us to write this x minus 4 times x minus 4 as x minus 4 quantity squared. And that would be our equation. We don't know what A is yet, but we have to have something to do next week. So number 2, x-intercepts. Well, it looks like it crosses at -1, crosses at 0, crosses at 3. So x equals -1, x equals 0, x equals 3. Any double or triple roots? No, they were all single roots, went right through the x-axis. Factored form, we're just going to translate all of these into factors. So it would have to be x plus 1. You could say x plus 0, and this would have to be x minus 3. Now when we write the equation, we're still going to put in that mystery multiplier because we don't know what the vertical scale is. They usually put the x out first, and then would be the x plus 1, the x minus 3. Order wouldn't matter. So this is a little faster than the other. What kind of graph was this? It looks kind of cubic to me, but it's coming down from the left. This one went up from the left. This one's coming down from the left. So this is going to be a negative cubic. which means whatever A is, A will have to be a negative number. That doesn't make this negative A. It means that A is going to have to be some negative number. Like A could be -2. What basic shape do you use? It's not perfect, but this is sort of the W. So this would be a quartic. And because it's opening upwards, this would be a positive quartic. X-intercepts. Well, crosses the graph at 0. And then it flattens and crosses at x equals 2. Do I have any multiple roots? Oh, yes. At x equals 2, because it flattened and crossed, that is a triple root. So when we write the factors, we'll have to consider that. Well, we'd change the sign here, but that would still make this. I'm going to put x plus 0 just for the heck of it. Could just put x. And then this is going to be a factor of x minus 2. And I'm deliberately writing it out 3 times. A lot of you don't need this step. So the equation is going to be y equals our mystery multiplier a times x times the quantity x minus 2 cubed. And that will be it. And said next week we'll find out how to find a.